subject of data structure and algorithm. The topic will be covered in this lecture: types of symbol table and dynamic program. First, type of symbol table. Data structure can be two types. First, static tree table and dynamic tree table. First, static tree table. In static tree data structure, the size of the structure is fixed. The content of the data structure can be modified but without changing the memory space allocated to it. Example of static tables are optimal binary search tree, Huffman coding. Next, dynamic tree table. In dynamic data structure, the size of data structure is not fixed and can be modified during the operation performed on it. Dynamic data structure are designed to facilitate changes the data structure in the runtime. Example of dynamic tree are AVL tree. Dynamic programming, the definition of says that it is a technique for solving a complex problem by first breaking into a collection of simple subproblems, solving each subproblem just once, and then storing their solution to avoid repetitive computation. Dynamic programming is mainly an optimization over pair recursion, where we see a recursive solution that has repeated calls for some inputs. We can optimize it using dynamic programming. The idea is to simply store the results of subproblems so that we do not have to recompute them when needed later. This simple optimization reduces time complexity from exponential to polynomial. For example, if we write simple recursive solution or Fibonacci numbers, we get exponential time complexity, and if we optimize it by storing solution of subproblems, time complexity reduces to linear. Recursive exponential and dynamic programming linear. Bellman principle of optimal. An optimal policy has the property that whatever the initial state and initial decision are, the remaining decision must be consistent. Optimal policy, the regard to the state resulting from the first decision. Dynamic programming work on the principle of optimally state that the an optimal sequence of decisions or choices. Its substance of must be optimal. If C belongs to an optimal path from A to B, then subpath A to C and C to B are also optimal or subpath, or an optimal path is. So we can say Bellman principle of optimally is related to the dynamic programming problem. Next, optimal binary search. As we know that a binary search tree, the node in the left subtree have lesser the value than the root node, and value in the right subtree have greater value than the right node. We know the key value of each node in the tree, and we also know the frequencies of each node in terms of searching, means how much time is required to search a node. The frequency and key value determine the overall cost of searching a node. The cost of searching is a very important factor in various applications. The overall cost of searching a node should be less. The time required to search a node in binary search tree is more than the balanced binary tree. As a balanced binary tree contains a lesser number of labels than binary search tree. There is one way that can reduce the cost of a binary search tree is known as optimal binary search tree. This is the structure of binary search tree. Problem: sorted set of key K1, K2, Kn. Key probabilities P1, P2, Pn. What tree structure has lowest expected cost? The cost of searching node, cost Ki equal to depth Ki plus 1. Expected cost of tree, summation of I equal to 1 n cost Ki and Pi. Summation of I equal to 1 depth Ki plus 1 into Pi. Summation of I equal to 1 depth Ki Pi plus summation of 1 Pi. Given K greater than K2, K2 greater than K3, K3 greater than K4. 3 K2 is divided by K1 K4 by null value. Optimal binary search tree must have trees or keys Ki, Kj, which is optimal for those keys that find best group. If it is not optimal improving, it will improve a concentration algorithm for finding optimal tree for sorted distinct key Ki and Kj for each possible route. Kr, Kij make optimal subtree for Ki, Kr minus 1 make optimal subtree for Kr plus 1, Kj. Select the route, give the best total formula. AI equal to expected number of comparison for optimal tree for case KIKJ. Formula of optimal binary search tree. Thank you friends for watching this video.